Okay, today we're going to talk about section 5.4, which is factoring and solving polynomial equations. It's going to be a review of factoring. We're going to apply the same rule of opposite x like we did before today to solve some equations. And we're going to look a little bit at factoring a little bit different way than we have in the past. Big key idea today that we're going to look at is factoring completely. That means taking things down all the way to its completely factored form. One of the keys here that I want to talk about is make sure we're recognizing the difference of squares that will show up again today. Lots of patterns will kind of continue to show up that we talked about in chapter 4. First off, a little review of factoring. We're going to look at these three polynomials. First one is going to be x cubed plus 2x squared minus 15x. A technique that we did not cover before is factoring by grouping. And what we're going to need to do there is first realize that I can't go right into my diamond problem yet because I have a common factor. The easiest way that I think of is to remove a common factor is to divide out that common factor. Last chapter, I made that big division sign. And that division sign is going to kind of show up again a couple more times today. So I'm going to separate it out and realize that we have a common factor of x here. And I'm going to dividing out x. And again, normally I would put it on top because that's division. We'd say I'm going to write x squared there plus 2x minus 15. If it's okay, I'm going to go ahead and write it on the bottom instead of the top. So again, x squared plus 2x minus 15. Again, I just removed out that common factor of x. Now, I'm going to prep my problem for factoring. And this should be familiar to us at this point of the game. Two things I'll multiply together to give me negative 15, add together to give me positive 2. Those two things are positive 5 and negative 3. At this point, we've got no reducing of that fraction, so that's going to be x plus 5. No reducing of that fraction, so that's going to be x minus 3. And we do need to remember to bring down that guy that we took out at the beginning, which is x. And that is now completely factored. The next one that I'm going to do is 2y to the 5th minus 18y cubed. Again, I'm going to divide out. Remember, just a big division sign. I tend to make it in boxes, but I want to show you what we're doing is dividing out a common factor. In this case, the greatest common factor between 2y to the 5th and negative 18y cubed would be 2y cubed. And that's because the y cubed goes both into the y to the 5th and the y cubed evenly. And I'm going to divide out below here. So that's going to give us y squared minus 9. Remember, we can multiply together. Yesterday we learned how to multiply these two things together. 2y cubed times y squared is 2y to the 5th. 2y cubed times negative 9 is negative 18y cubed. Goes in, comes back out. So now my factor is 2y cubed times y squared minus 9. This is the idea, hey, I warned you guys earlier, y squared minus 9 is not factored completely. In fact, this is the difference of squares. And the difference of squares will factor to y plus 3 in this case, and y minus 3 again. Square root of y squared is y, square root of 9 is positive negative 3, and we will bring down the first factor, 2y cubed. Factoring completely. Next one, we're going to look at 4z to the 4th minus 16z cubed plus 16z squared. Once again, we're looking at factoring completely. I'm looking at the problem. I need to divide out the greatest common factor. The biggest thing goes into 4, negative 16 and 16 is a positive 4. I've got a z to the 4th, z cubed, and z squared. The biggest thing that goes into all those evenly is the z squared. When you're dividing out like that, the thing that will go in the most will be whatever the smallest polynomial expression is. So we got z4, z cubed, and z squared. The thing that can divide out is the z squared. 4z squared is taken out. I divorce 4z to the fourth. That will leave me a z squared again. Notice we multiply together. If I'm going to multiply those exponents, 2 plus 2 is 4. That's how I'm getting that. Take out a 4z squared for the middle expression. That will leave me a 4z. And take out a 4z squared from 16z squared. That gives me a positive 4. Again, you can always check your work by multiplying these things back together. The 4z squared times z squared is 4z to the fourth. 4z squared times negative 4z is negative 16z cubed. And 4z squared times positive 4 is 16z squared. At this point, I need to continue factoring, factor completely. Set up my problem. That's a 4, a negative 4. I have a z. I have a z. Two numbers that multiply together to give me 4 and add together to give me negative 4. Those two numbers are negative 2 and negative 2. So I'll write my factored form. Those fractions don't reduce. I have a z minus 2 times a z minus 2. And I will bring down my first factor. 4z squared. And I'm okay with 4z squared times z minus 2 squared also. I'll take either one of those. They say the same thing. Next up, sum and difference of cubes. There is a technique there. If you like patterns, go ahead and memorize the pattern. If you see what's happening there, you can go with that. I'm going to show you a way that I remember it, which isn't really memorizing patterns. It's just kind of working out of the box that we used yesterday. Yesterday when we multiplied, today we're dividing. So we multiplied to get to the answers inside the box. Today we're going to divide. So again, we're taking things out of that box. So x cubed plus 64. The first thing that I'm going to recognize is that x cubed and 64 are both perfect cubes. So what we need to do in this case is rewrite it. And if I rewrite it, I'm going to write it as x cubed plus, and that is 4 cubed. Again, I recognize that this is a sum of cubes. I know that the sum and difference of cubes will factor to nice things for me. So I've got it rewritten, and here's what I will do. I'm going to set up a 2 by 3 box. I know one of my factors, I've taken that out, will be x plus 4. I'm getting that right from there. And then I know, since I'm dividing out, inside my box, I have to have an x cubed and a 64. The x cubed will go here. The 64 will go here. I know all my middle terms now because all I have is x cubed plus 64. All my middle terms will have to drop out. So if I know that all my middle terms will drop out, I'm going to work backwards to solve for this box. If we look on just the top line, if I look at just the top line there with the red x cubed and the x, and I think about it in terms of division, then I know that x goes into x cubed. That leaves me with an x squared, just like we had before. Now, if that's an x squared, and then I have a 4 down here, I have 4 times x squared, so that will give me a 4x squared in the box. Since I want things to cancel out, because again, x cubed plus 64 doesn't have any guts, it doesn't have any middle terms to it. If that's a 4x squared there, I need to have a negative 4x squared up here. Once again, if I have a negative 4x squared and I factored out an x, it should tell you that, hey, this term now needs to be a negative 4x because negative 4x times x is negative 4x squared. At that point, I can multiply my negative 4x times my positive 4, and that will give me a negative 16x here. Since I want all of my terms, once again, to cancel out, because I have x cubed plus 64, that means if I have a negative 16x here, I have to have a positive 16x in that location so that it does cancel out. And if I've taken out the x and I'm left with 16x there, this must be a positive 16. That's the only way that'll make that work. And at the end, you have a check. Double check to make that positive 4 times positive 16 equals positive 64. And it does. So that's how we factor the sum of cubes. My factors are what's going to be on the outside. I know the inside is what I started with. That was x cubed plus 64. So my factor here will be written as x plus 4 times x squared minus 4x plus 16. Now, we talked about factoring completely. You can try and factor that. It will not be factorable. Once you factor the sum and difference of cubes, that next expression will not be factorable. So x plus 4 times x squared minus 4x plus 16 is the factored form of x cubed plus 64. Next up, we're going to look at the 16z to the 5th minus 250z squared. Hopefully, you're starting to see the pattern. 16z to the 5th minus 250z squared. Remember, you want to take out that common factor first. In this case, we can definitely take out a z cubed. I don't know if there's something in common with the the 16 and the negative 250. We're going to take out a factor of 2 there. When I take out a factor of 2, that's going to leave me with 8z cubed. And let's see, that goes in, what do we got, 125, is that right? Minus 125. So I've removed my common factor. We did that in the previous problem. As I said, today is about factoring completely. So now we're looking at 8z cubed minus 125. I've recognized, or it's starting to look like, these are perfect cubes. So I'm going to do my rewrite. I'm going to rewrite 8z cubed as 2z squared, because 2z times 2z times 2z is 8z cubed. I said squared there, I mean cubed, sorry about that. And then I'm going to write this as 125. I'm going to write that as 5 cubed. Same game as before. I'm going to set up my rectangle. I want everything to cancel out. I know my top term has to be 8z cubed. My bottom term needs to be negative 125. And I know one of my factors will be 2z minus 5. At this point, you can work and solve the puzzle. Covering up 2z and 8z cubed, that will be a 4z squared. If that's a 4z squared times negative 5, that will give me a negative 20z squared. I want my guts to cancel out, or the insides of the rectangle cancel out. If that's a negative 20z squared, this will be a 20z squared. If that's a 20z squared, I'm dividing out a 2z. That will leave me a 10z up top. That's a 10z up top. Multiply my 10z by negative 5. Negative 5 times 10z is negative 50z. Once again, I want to get my middle to drop because the only thing that I'm allowed to factor is 8z cubed and negative 125. 8z cubed and negative 125. So I got a negative 50z. That means that has to be a positive 50z, so that drops. And make sure it matches up. 2z is factored out. We've got a 50z there. That should be a 25. You'll double check your work. 25 times negative 5 is indeed negative 125. So now, once again, we've got our factored form, and that's going to be 2z minus 5. Remember, your factors are what's on the outside, times 4z squared plus 10z plus 25. And don't forget about the guy at the very beginning, Mr. 2z squared. You factored him out. So there is your completely factored form of 16z to the 5th minus 250z squared. Once again, you can try to factor that 4z squared plus 10z plus 25. I'll tell you it's not factorable. Next up, you guys. You can start on that. I would encourage you to try 1 or 2 at this point, just to make sure that you're matching up with what I just did, instead of sitting on it and bringing it to class the next day and starting it in class. So maybe pause the video and work on 1 or 2 of those. Next up, we're going to look at factoring the polynomial. We got x cubed minus 3x squared minus 16x plus 48. This technique I actually really like. We're going to use it quite a bit. It's called factoring by grouping. And here's the step. You're going to use factoring by grouping when you have 1, 2, 3, 4. You're going to use factoring by grouping when there's 4 terms. That's your key. Factoring by grouping I like. It's pretty straightforward. We've got x cubed minus 3x squared minus 16x plus 48. With factoring by grouping, as I already told you, we're going to think about removing a common factor. You've seen that before, dividing out a common factor. This is the way you've seen it. And again, we've dealt with the box yesterday and some more today. So don't be afraid of the box. There's 4 different terms, so we've got it in 4 sections. Now, hopefully you'll agree with me. If I'm looking at x cubed minus 3x squared, negative 16x and 48, there's nothing in common that I can remove in order to factor this. So here's what factoring by grouping does. It says, don't look at the whole expression. Instead, I only want you to look at the left 2 terms. And then we're going to look at the right 2 terms. But for factoring by grouping, that's when there's 4 terms. Like I said, you're going to set it into 4 groups. Cover up the right-hand side. That's what I say. Cover up the right-hand side. Look only at the left-hand side. If I'm looking only at the left-hand side, I've got an x cubed and a negative 3x squared. The greatest common factor that I can take out between an x cubed and a negative 3x squared is an x squared. If I take out an x squared, that gives me an x here. If I've taken out an x squared, that gives me a negative 3 there. Factored on the left. Next part. Mr. Wood, what about that stuff on the right? We can't just leave it there. That's right. We will now cover up the left-hand side and look only at the right-hand side. Looking at negative 16x and positive 48, we want to figure out the greatest common factor that we can pull out there. And that factor is going to be what? Negative 16. If I pull out negative 16, I'm just going to write it right there. Because again, remember, we've covered up that left-hand side, so I'm dividing out from the right-hand side. Negative 16 is the greatest common factor there. And now we're going to multiply. Let's get it back in. Negative 16x divided by negative 16. We should agree. Again, I'm looking only at the right-hand side. That should be an x. And then let's see. Negative 16 times negative 3 gives me positive 48. So when we've got 4 terms, and we're going to factor by grouping, we cover up the right-hand side and factor the left 2 terms. Then we cover up the right-hand side and factor the left, cover up the left, and factor the right-hand side. When you're done, it looks something like that. But what I want to point out is we've removed a common factor of x minus 3 on the left two terms. I've also removed a factor of x minus 3 on my right two terms. In fact, x minus 3 here is my common factor. X minus 3 is the thing that I factored out. On the left, I factored out an x squared. On the right, I factored out a negative 16. So that's how we write that factor. When we factor by grouping, we put it into four terms, cover up the right, factor the left. Cover up the left, factor the right. My answers on top must match. In this case, x minus 3, x minus 3. X minus 3 is the common factor. You have done it incorrectly if your top terms don't match. So x minus 3, and then your other factors are x squared minus 16. Mr. Wood, that's not that bad. I got this. It's pretty easy. Yep. Of course, I'm going to tell you right now, this is not factored completely. You need to recognize that x squared minus 16 will factor as the difference of squares. And x minus 3, you still factor. So that is now factored completely. X minus 3 times x plus 4 times x minus 4. Factored completely. Again, factoring completely. That's what we got to do here. 16x to the fourth minus 81. That's the next thing we're looking at. And what I'm going to want to do there, I'll just tell you, that's the difference of squares. It doesn't look like the difference of squares, but everything can be square rooted. The square root of 16x to the fourth is 4x squared. The square root of 81 is 9. Remember, one of our signs needs to be positive, and one of our signs needs to be negative. Sweet. We're done. Factor the difference of squares. That wasn't that bad. I see that this is a perfect square and that's a perfect square. I can factor using the difference of squares. We're not done. Why? Because this 4x squared minus 9 is also the difference of squares. 4x squared will factor to 2x and 2x, or 4x squared square rooted. Square root of 9, positive 3, and negative 3. So 4x squared minus 9 factors 2x plus 3, 2x minus 3. 4x squared plus 9 is not factorable because it's not a difference of squares. A difference of squares is factorable. Difference of squares is factorable. Sum of squares is not factorable. Sum of squares is not factorable. With cubes, what I showed you guys earlier, you can factor sum and difference of cubes. Both work. Next up, 2b to the 8th plus 10b to the 5th plus 12p squared. I said b's instead of p's, sorry about that. 2p to the 8th plus 10p to the 5th plus 12p. Hopefully you're getting the hang of this. I'm going to start going a little bit faster. 2p to the 8th plus 10p to the 5th plus 12p squared. Taking out a common factor first. In this case, I can take out a 2p squared. If I take out a 2p squared, that will leave me p to the 6th plus 5p cubed plus 6. That looks pretty good. We're not done. We can still factor this. As long as my terms match as half. X to the fourth, x squared. P to the sixth, p cubed. X squared, x to the 1. In my trinomial, I can try to factor it. So 6 up top, 5 down here. This time I will have p cubed over p cubed over. This is my prep work for factoring. Take a second to see where that's come from and see that we are setting it up just like we've done in the quadratics chapter when we factor. Two numbers need to multiply together to give me positive 6, add together to give me positive 5. Those numbers are 3 and 2. Now we can go ahead and write it. I can't reduce those fractions, so I've got p cubed plus 3, p cubed plus 2, and don't forget the original factor that you factored out, which is 2p squared. We are factored completely here. The only thing that I would remind you of is double check. Discount double check, Aaron Rodgers. Double check p cubed plus 3. Make sure that's not a factorable sum or difference of cubes. Double check that p cubed plus 2 is not a sum or difference of cubes. Although p cubed is a cube, 3 is not a cube, and 2 is not a cube. So I can't factor this down any further. So that's my answer. You guys will do that. Real number solutions. 3x to the fifth plus 15x equals 18x cubed. We've got to solve that. It's not that bad. It looks bad. It's not. 3x to the fifth plus 15x equals 18x cubed. Well, I'll tell you, for solving these equations, just like with quadratics, we've got to get one side equal to 0. That means move all your stuff over. In this case, I'm going to minus 18x cubed from both sides of the equation. That's going to give me 3x to the fifth minus 18x cubed plus 15x equal to 0. Name of the game today is factoring. 3x to the fifth minus 18x cubed plus 15x. You guys know how to factor that. We've been factoring all day. I will divide out my greatest common factor. I've got a 3x to the fifth, negative 18x cubed, and a positive 15x. I will divide out a 3x. That now gives me x to the fourth minus 6x squared plus 5. Great, Mr. Wood. Why are we factoring? I'll tell you why. We're going to keep factoring. As I told you in that previous problem, as long as our exponents go 4 and then half of that, we can factor. So 4, 2, nothing, we can factor. Exponent 4, exponent 2, we do this. 5 times 1 is 5. I'm going to bring down negative 6. Problem of the problem. That's x to the fourth. That means I'll have an x squared and an x squared here. Problem's prepped. Two numbers that multiply to give me 5, add together to give me negative 6. Hopefully, what do we got there? Negative 5, negative 1. I can't reduce either of those fractions, so I'm going to write it. That's x squared minus 5. That's x squared minus 1. Don't forget about the guy you factored out at the beginning. He's 3x. Oh yeah, this was an equation that was all equal to 0. Are we done yet? No, we haven't factored everything completely. Well, 3x is good. Yeah. X squared minus 5, that's good. That's not the difference of squares. But x squared minus 1, he is the difference of squares. That will factor to x plus 1, x minus 1. Still have the x squared minus 5. And I still have the 3x. Now we've got that factor completely. How do we solve it? I'm glad you asked. The name of the game when we're solving and we have it equal to 0 is opposite x. X equals positive 1 there. Opposite x. X equals -1 here. We'll come back to this guy. 3x. What do you mean opposite x? What is the opposite of that? I don't know. Well, hopefully you'll think back and remember. We talked about this briefly before. I said, hey, if you can't do the opposite x in your head, if you can't do it in your head, just set it equal to 0 and solve. Oh, I can do that. 3x equals 0. If I divide both sides of the equation by 3, then x equals 0. Cool. We've got a root or a solution. We've got a root or a solution. We've got a root or a solution. X squared minus 5. I can't solve that in my head. No, you can't. But I can solve it by setting it equal to 0. And we have the technique to solve this because we can solve it by square rooting. Add 5 to both sides of the equation. X squared equals 5. I'll square root both sides. When you as a mathematician introduce a square root, remember you need to put plus or minus. Square root of x squared is x plus or minus the square root of 5. Solving a quadratic equation. We've solved by square rooting here, and we've solved by factoring. Notice, in this problem, I actually have 1, 2, 3, 4, and 5 solutions, or 5 roots. Remember that at some point we're going to be graphing this. That means this graph, 3x to the 5th plus 15x minus 18x cubed equals 0, that graph, when we graph it, is going to touch at 5 locations. And again, our choice is going to be choice D. That's the one that has all 5 of our roots. Notice that 0 is there, -1, +1, and positive and negative root 5. All 5 of our roots are there. Factoring completely and zero product property. Opposite x. It's tedious. It's not a long, it is a long problem. It's not a difficult problem. Factor, 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 factor. That'll be you guys. Last problem we're going to look at. You're designing a marble basin that will hold a fountain for a city park. The basin's sides and bottom should be 1 foot thick. That's saying how thick this basin is. At least they've given us a picture. They're talking about the thickness, and I don't know if this color is showing up for you guys. But it wants to be 1 foot thick. Its outer length should be twice its outer width and outer height. So it's telling you that the height is going to be something, and the width is going to be something. But whatever that distance is, it wants its length to be double that distance. And like I said, they've given you a nice little picture here where it has actually put the x's and the 2x in there for you. So they gave it to you. What should the outer dimensions of the basin be if it's to hold 36 cubic feet of water? In other words, I'm going to be dumping in 36 feet of water, cubic feet of water, on the inside. So they've given me the volume on the inside, and that's 36 cubic feet. Well, what do I know about volume? I know volume is length times width times height. And probably some of you are thinking, I'm just going to go length times width times height. They gave me the length, width, and height there. And I'm just going to multiply them. That's a 2x, that's an x, and that's an x. I'm just going to multiply them together and set that equal to 36. Well, that's not quite right. The reason that that's not quite right is those are the outsides. 2x is the length on the outside here. X is the length on the outside, and X is the length on the outside. Unfortunately, my water is getting dumped on the inside. So my volume of water is here. That's 36 cubic feet. Well, my volume only goes that. I haven't accounted for that thickness. So what I want to do is take into account that thickness. The way that I'm going to do it is, well, I know that that dimensions around it, and now I'm going to look at a top-down view. So you got to kind of help me out and help visualize. This is me looking down at the top of that basin. You know that this side is X and that side is X. They also told you that the distance right here is 1 foot, which means that distance is 1 foot, which means that distance is 1 foot, which means that distance is 1 foot. All these distances around are 1 foot. Oh, I forgot to put 2x there. There you go. So I know that the overall distance on the outside from here to here is 2x. But if I want the inside distance, what I have in black there, that's going to be the outside distance, 2x, but I need to take away my 1 foot of length and that 1 foot of length. So my black line distance, which is the inside, will be 2x minus 2. Again, minus a foot, minus a foot. The other length, we'll look at it here. I have it in green. I know the outer length is x, but the distance of the inner, again, this is top down looking at the basin, inner length that I have in green there will be x minus 1, 2. Okay? So that's how I'm getting that. 2x minus 2 and x minus 2. At this point, we know that our side length is the same length as our height. So if our side length is x minus 2, we know that the height is also going to be x minus 2. So that should have the makings now of an equation, because volume is length times width times height. Our volume on the inside, again, remember we're putting it inside, so we're looking at that small rectangle, is going to be 2x minus 2 times x minus 2 times the height, which is also x minus 2. And that's the same height as width that was given to us in the problem. I am going to do some magic math at this point. We have to multiply all of those together, 2x minus 2, x minus 2, and x minus 2. On the left side, it's going to be 36. What it's going to be is 2x cubed minus 8x squared plus 10x, and that is going to be a negative 8. No, that's not right. Negative, did I make a mistake here? Negative 4? That should be right. I think this is supposed to be an x minus 1. And we'll talk about that in class, so I'll come back and explain. If you're wondering why that third length is an x minus 1, it has to do when we look at that other dimension and not counting it twice. We'll cover that one part in class on when we talk next. Now we need to solve this equation. I will minus 36 from both sides. I have 0 equals 2x cubed minus 8x squared plus 10x minus 40. We're going to look for taking out a common factor. Let's see, I don't think I can remove anything in common. What I am going to do is go ahead and factor by grouping here. Once again, factor by grouping, cover up the right-hand side, look only at the left. Looking at the left two numbers, 2x cubed, negative 8x squared. I will take out a 2x squared. If I take out a 2x squared, that will leave me an x minus 4. Cover up the left-hand side, look only at the right-hand side. Greatest common factor between 10x and negative 40 will be a, what do we got, a 10 there. If I take out a 10, multiplying back in, remember, when I'm looking at the right-hand side, I take out a factor of 10, that will give me an x, and minus 4, negative 4 times 10 is negative 40. You know you factored by grouping correctly when your factors up top, x minus 4, that's the common factor. X minus 4 is the common factor. And then you have 2x squared plus 10. And that's your other factor. And that's equal to 0. We still need to solve it. That's easy enough to solve. Opposite x. X equals 4. 2x squared plus 10. I can't do that one in my head, Mr. Wood. Okay. 2x squared plus 10. Set it equal to 0 and solve. I'm going to minus 10 from both sides. That gives me 2x squared equals negative 10. Divide both sides by 2. That's going to give me x squared equals negative 5. At that point, I'm going to go ahead and square root both sides. Some of you can see where this is heading to. There's my plus or minus. Square root both sides. I'm taking the square root of negative 5, which you guys should realize is plus or minus I root 5. I have solutions here. 2 of them are imaginary and only 1's real. Let's see. I'm talking about the sides of some sort of tank that I'm going to build in the middle of town. Hopefully it makes sense to you that x has to be equal to 4, and I cannot use those as a solution. So side length should be 4, 4, and then double that, which is 8. Those should be the dimensions, 8 foot by 4 foot by 4 foot. All right, and that's it. You guys can go on, got it breakfast.